Welcome to this session on network security and forensics. Until now we have been talking about how to collect evidence. We saw that we might have to attach ourselves physically to the network to collect evidence, and if the evidence is collected live, it is active evidence. If the evidence is collected and stored, or you take it from some storage medium, okay, it is passive. We can call it as a static or a passive kind of evidence. Essentially, we will look at one tool which is Wireshark, which can be used to collect data packets. And if you remember, the process what we have tried to do was that we want to collect whatever is the data packet that is flowing in the network to which we are connected, and then start gathering evidences. So, this was one of our aims in this network forensics course. So, what we will do now is we will take a look at Wireshark, which is used for capturing the packets. This will be a sort of hands on. So, we are going to only give an introduction for about 15 to 20 minutes about this Wireshark tool. So, you need to work much more on various problems of how to collect data, how to collect series of data, how to identify the flows using Wireshark. There are also other tools such as T-Shark, but we will be mostly concentrating on Wireshark because it is slightly easier to explain Wireshark since it consists of a nice graphical user interface. This Wireshark tool is actually found in Kali Linux, which probably you are very familiar with and which you have been using. So, you need not separately install this, and if you have Kali Linux, you can start using Wireshark. You can invoke Wireshark by doing the following operation. Okay, you can do a sudo command and then invoke Wireshark. So, this is in Ubuntu systems. For other systems, fine, you have to become a super user. You become a super user and try to invoke Wireshark. Otherwise, what you can do is you can get necessary permissions to access the Ethernet interface and then use Wireshark. So, once you invoke Wireshark, you get a nice GUI something like this. So, if you look at this, it says that error during loading, and it says do file has been disabled due to Wireshark running as super user. Okay, you can just ignore it for the time being. If you want to find out what this message is, just go to the web and check. Now, our idea here is to capture the evidence. So, we are not bothered about all these messages. So, what we will do is we will just press OK, and then once we go here, you see this is the main screen of Wireshark, and it might vary depending on what version of Wireshark you use, but in general Wireshark you will have these kind of screens where you can just open the previously captured packet, or you can capture the packets live. Okay. So, in this case, for example, we are using Wireshark 2.2.6, probably you could get some other version of Wireshark which is in your Kali Linux. Now, the idea is we want to capture the data from Ethernet interface. Okay. So, at least in this case, if you have a wireless interface, you could that wireless interface will also be shown here. So, the idea is that we will go ahead and capture data. So, what we will do is we will just go ahead and then double click on this ETH0 to capture the data. So, here we have double clicked it, and once you have double clicked it, you see that Wireshark has started to capture the data packets. Now, if you look at this, the Wireshark actually, I mean it divides. I mean, one of the things that you should be careful is that whether I will get all these 3 partitions of the screens, etc. It depends on what is the configuration you are going to do for Wireshark. We will look into it shortly, but then in general, once you open Wireshark, it will have 3 partitions. The first partition shows the packets, the second partition shows each of the packets, and the third partition shows the values in hex. So, if you look at this part, okay, you see that it displays the number of packets that are collected. So, and the number of packets that are displayed. So, if you look at this, since it is live, you see that the packets are increasing. We will collect about 100 packets and then stop. So, we can go ahead and stop Wireshark after collecting about 100 packets. So, now we have stopped Wireshark, and once we have stopped capturing, okay, so this gives you if you look at this, we have different, so it starts, the packet numbers are sequenced something like this, it has the sequence number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. This is the packets, the independence packets that are flowing and that get captured by Wireshark. The second one is it shows the time starts in the current time. So, the 0th packet, I mean the first packet is caught at the 0th time, I mean this can be changed, okay. So, we will see how this can be changed. Then it talks about the source address, the destination address, the protocol, what is the kind of protocol that it has captured, then it finds out the length of the packet, and then what is the info that it can decipher. See, many a time we might have to do this hard work of inferring what is there inside the packet, but to some extent this Wireshark provides you some basic information about the packets that it tries to interpret, okay. Now, moving on, so if you look at this, you have various options, you can open files, you can save as files. So, what we are going to do right now is we just have to, whatever packets that we have captured about 100 packets, we will just store it in the /tmp directory, okay. So, just I mean this just experimental purposes. So, this is how you actually acquire the data. So, what we are doing right now is there are various formats, you can even zip it, etc., but we will, for the time being, we will just capture it in pcap-ng format. So, I am just overwriting a file. If you want, you can create a new file or you can overwrite a file. So, in this case, for example, I am overwriting sample Wireshark pcap-ng. So, I am just replacing that file and the data gets saved. So, what I can do right now is that I can actually, having saved the data, I can now remember we had told you that we should always work on a copy of the data and not on the real data, that is why we are actually storing the data. So, then these are all the packets that this guy has captured. So, as I told you, there is a time field, source field, destination, protocol length, and then info, etc. Okay, the protocols, so one of the things that you should be aware is that as a network forensic expert, we should be aware of many of the protocols that are there in the internet. We will tell you, I mean, where this information on the protocols can be found. One of the advantages of using Wireshark is that you can actually, if for example, the protocol is not a standard protocol that is proposed by Internet Engineering Task Force and it is a proprietary protocol. If you get information about this proprietary protocol, you can actually write scripts in a language called Lua, and then you can actually integrate it with Wireshark. So, many a time you might have to do this, because while doing forensics you might have to do a lot of scripting, and that is one of the reasons in the previous course we talked about one scripting language, which is the shell scripts. You might have to write code in Python or Ruby or I mean the Lua programming language, anything. I mean you might have to be familiar with at least one of these programming languages, so that you can write your own protocol interpreter, okay, and integrate it with Wireshark. Okay, we will see how these things are done, but not in detail, but we will be doing some case studies and we will show how these things are done. Okay. Now, what this tells you is that you should be aware of almost all the protocols that are there in the internet, and which is quite impossible. So, you should have the ability to understand a protocol and then try to write scripts whereby the protocols can be interpreted, okay, that is more important. So, in this case, for example, we can see a RIP version 1 protocol and RIP version 2 protocol, and as I told you, the second window here, the second partition here actually shows what is being carried by this packet. So, if you look at this, it has a Ethernet frame, okay, and it has a Internet Protocol version 4. So, IP is being used, and if you see this is the broadcast address for the subnet. So, there is a router that is broadcasting its routes, okay, and it uses the UDP and it uses the routing information protocol. One of the things that you should note in this is that if for example, I just open this routing information protocol, now I can go on expanding this routing information protocol. So, if you look, one of the ways to find out how this correlates with the RIP protocol is that if you go to the corresponding RFC, which so the RFC's numbers usually changes, okay, as they make updates to protocols. So, you can just go to IETF website and then check what is the current RFC for this. Now, in that they would have given a packet format, okay, for RIP. So, this RIP request and then there is a response and things like that. So, this is RIP version 1, and then it tells you what are all the IP addresses that it is carrying, essentially the routing table that it is carrying or the routes that are reachable. So, you will get this kind of format, and Wireshark helps you identify, read these things in a much better way by interpreting it with the standard diagrams that is given in the RFCs. Okay. So, here we are talking about the route metrics, and if you click on one of this route metrics, for example, that will actually go ahead and, for example, I mean if you look at this, we are looking at the RIP v2 packet now. The RIP v2 packet has more information than RIP v1 packet. Essentially, I mean it has more information, and what we do is, now if you just click on one of the what should I say, the fields, okay. For example, we are clicking on source port field 520. Now, once you click on this field, look at this here, okay. So, there is a blue color that is, so it tells you that this hex value, okay, corresponds to this source port field. So, either you can click on the values here, then the values will be highlighted, or you click on the values here, the values will be highlighted. So, this tells you that in the packet, okay, this field corresponds to the source port. Similarly, I can identify other stuff. For example, the destination port is also identified 0208, and then if you look at this, I mean remember this is in hex. So, 84 is 16 into 8 plus 4, okay, that is so 132, okay. So, that is 128 plus 4, that is 132. So, these are all hex numbers, whereas this guy is clearly for easy readability, it is printing it in decimal format. Of course, hex numbers are printed as 0x. So, if you look at this, the checksum is this, and the checksum it says is unverified, which is okay. Similarly, you can identify for internet protocol, okay, internet protocol we are using IPv4, and looking at the IP address we can say IPv4, this is an IPv6 packet, okay. So, you can identify what type of protocol that we have captured. So, it also tells you that there is a spanning tree. So, there is this D-link switch is actually getting a spanning tree protocol, okay, STP, trying to identify the spanning tree in order to avoid cycles, etc. So, in this way you will be able to interpret many of the fields, but for this you might have to have your RFC next to you to understand what this field means and all those specific details, okay. Now, why are these specific details needed? Because you might have to present a report, and in the report you might have to underline what are these fields and why these fields correlate as evidence, okay. So, similarly, I mean like what we have done, this can be done for each of the protocol that it carries. So, in this case, for example, if we if we can identify, we can just press our button on some particular hex value, then we will be able to see what that value is. For example, 11 is actually 17. So, it tells you that the IP is carrying a UDP protocol on top of it. So, in this way we will be able to, each packet can be analyzed. Now, let us try to see how this analysis can be done. For example, let us say that I want to track what are all the data packets that are emanating from one machine, particular machine. So, in this case I can actually do a sorting based on the machine ID. So, if you look at this, what I have done right now is I have just clicked on the source tab and it sorts according to the IP addresses. So, in this way I will be able to capture what are all the data packets that are gone from a particular source machine. Now, similarly I can do it. So, if you look at this here you see that 192.168.1.245 has communicated with 192 and has sent a broadcast request, and it has also sent a request to a RIP VT request to 224.0.0.9 and so on. So, in this way I will be, so 249 is talked with so many other routers, okay. Now, remember all these data can actually be presented in the form of a graph, and then we can later go and find out the connectivity of the network, who are all the people that I have tried to contact and all those things. So, this actually spans, I mean this goes into something known as network discovery part. So, each data that is available here, okay, can be used for very many purposes, but we just wanted to present you that what is the kind of information that Wireshark provides you. Now, so you can sort according to the source address, or you can sort according to the destination address or the protocol. So, if you look at this, we have this many types of SNMP protocol. So, the SNMP protocol, there is 0.10 has generated lot of traps. So, and it also tells you at what time these traps are generated and so on. So, and you can even sort according to the length of the packets. So, it provides you a huge amount of search opportunities, sorting opportunities, etc. I mean, the idea is that if you just put the data in a different format, you may come to a different conclusion. Okay. So, because of this tool provides you all the facilities that are needed. Okay. Now, what are all the other things that this tool? So, if you go to each one of the tab that is given, so if you look at this, you see that there is a packet list, there is a packet details and packet bytes. Now, this corresponds to packet list, this corresponds to packet details, and this corresponds to packet bytes. So, in this way, okay, so you can enable or disable whatever you want. So, and if you look at the time field, I said the time field started with 0, but actually what you can do is, if you go to this time display format, then this gives you lot of ways. See, what we have done is second since beginning of capture, that is what we have done. So, what we can do is we can even do with time of the day, date and time of the day, etc. So, this provides you a lot of facilities. You can even do tenths of a second, hundred of a second, and milliseconds, and etc. Okay, so if you look at, I mean, please go through all these tabs and then try to find out. You can see for easy readability, this also you can also color the packets. Okay, so if you look at this, we have just pressed on this tab to color the packets, and you can also remove the coloring by clicking on it. Okay, so now the colors have been improved. So, now you can also traverse from one packet to another packet using the Go tab. We can also do filters. Okay, this is very important because this Wireshark dumps a lot of packets, and we do not need all the packets. I mean, what if I am going to analyze who is the person who is talking to another person, why do I need RIP packets? So, in order to do this, what we can do is we can apply filters. Okay. This filter just tells you that only those packets that satisfy the filter condition are displayed, the rest of the packets are not shown. So, there are many ways to apply filter. One is you can go and type in this apply a display filter column, okay, or what you can do is you can, on a selected packet, you can just apply a filter, okay, and in which case you see this, it just tells you all the routing protocols like RIP v1 and RIP v2. So, what we are saying in this case is, if whatever is, if the IP source address is 192.168.1.245, just display those packets. So, essentially we can know that this guy is a router, okay, and this router is trying to I mean, people who have configured the router. Now, look at the information that we can get. We can find out that the people have configured both RIP v1 and v2. I do not know for why. They have also done OSPF. Okay, so this tells you that this guy is configured for OSPF, and for example, if none of the other routers are there in OSP are there using OSPF, we can actually disable this protocol. Otherwise, this just hello packets just occupy bandwidth. So, even some kind of performance optimization can, if information can be obtained by using Wireshark. Okay, this is a very important tool that the network administrators use, and it is also used very largely by forensics experts. Okay, and if you want to clear off, just press that cross button. So, it clears off and then it again starts displaying almost all the packets. So, this is one of the ways by which you can actually capture the packets that are flowing in the network. The next one we can do is so you can capture, you can do analysis, you can get some kind of statistics, and if you look at what is happening is that you can also look at for example, telephony. For telephony, what are all the certain kinds of protocols? Okay. So, for telephony protocols, you can actually specifically do the capture those particular packets. Okay, you can do a lot of statistics. For example, I can find out the IPv4 statistics for all address, then for telephony, then wireless, then you can have some ACL rules, etc., access control list, etc. As I told you, one of the things, and after that you can go ahead and quit it. Now, if you remember, we had actually stored the packet. Now we showed only the live. Now we can go and store the packet, and then we know we knew that we are storing the packet as pcap ng. If you double click on that, so you are able to retrieve all those packets whatever you had stored in the previous session. So this gives you a very good interface, okay, for capturing packets. Thank you very much.